In this video, I will be explaining on how we can evaluate indefinite integrals. I will also explain several examples involving the different basic rules in integration or anti-differentiation. So in evaluating indefinite integrals, we can express it by its basic form, the indefinite integral of function f of x dx, which is equal to the antiderivative or the antidifferentiation of f of x plus the arbitrary constant c. So from our previous videos, we already learned about the basic rules in integration or anti-differentiation. So they are the power rule, constant multiple rule, sum and difference rule, and others. So we will apply them on the following examples that we will discuss in this video. For our first example, we have the indefinite integral of x cubed dx. So we see that our x has an exponent, so we can simply identify that we can apply the power rule. So in power rule for integration, we add 1 to our exponent and we will make its sum equal to our denominator. And then we add the arbitrary constant c. Then after that, we can just simplify that by adding the 3 and 1. So we have x raised to 4 over 4 plus the arbitrary constant c. So therefore, the antiderivative or the indefinite integral of our function x cubed dx is equal to x raised to 4 over 4 plus c. So let us proceed to our second example. We have the indefinite integral of 9x dx. So in this given example, we can see that we have a constant of 9. So therefore, we can simply apply the constant multiple rule because we have a constant 9 multiplied to our function x. So the first thing that we will do is we separate our constant 9 by the integral operator to our function x and then dx. After we separate our constant 9, we then apply the power rule, which means we will add 1 to our exponent and we'll make it as our denominator, and then we add the arbitrary constant. So after that, we just simplify the exponent and our denominator and we get 2. So now we have to multiply our constant 9 to our x squared over 2 plus c. So therefore, as we simplify that, we get 9x squared over 2 plus c. So therefore, the indefinite integral of our function 9x dx is simply 9x squared over 2 plus c. So for our third example, we have the integral of 10x raised to 5 dx. So in evaluating its indefinite integral, we have to look at our constant 10 so that we can apply the constant multiple rule. So in constant multiple rule, we simply separate our constant 10 from our function through the integral operator, and then we have 10 times the indefinite integral of x raised to 5 dx. Then after that, we apply power rule to our x by adding 1 to our exponent 5 and then making it as the denominator plus the arbitrary constant c. And then we can simplify its exponent. 5 plus 1 equals 6, and then the denominator as 6. So after that, we can now multiply our constant. 10 times x raised to 6 is equal to 10x to the power of 6 over 6 plus c. So therefore, the indefinite integral of our function 10x raised to 5 dx is equal to 5x raised to 6 over 3 plus c, because 10x raised to 6 over 6. So we see that 10 and 6 has a common factor of 2. So therefore, we'll divide them by 2, and then we get 5x or 5/3 x raised to 6 plus c as the value of our indefinite integral.